So let's take another quick look at the beginning and ending addresses for our encoding scheme. We'll copy the start address and we'll start our stub by placing this address in EAX. It will serve as a counter for us. So let's move into EAX, our starting address. Now comes in our encoding scheme, where we XOR the data pointed to by this address. So we'll quickly type XOR, and we want to XOR the byte that is being pointed to by EAX. And we'll use an XOR key of 0F. This is a random key I'm choosing right now. We can use any key we like, as long as the same key is being used to decode the stub. So what this instruction will do is it will XOR the byte that is being pointed to by the address of the beginning of the encoding scheme. Once that's done, we'll want to increase our pointer, our EAX pointer, by 1, and check whether we have reached the end of our encoding address. And we can do that by comparing EAX with our end address, which is here. If we've reached that address, we'd like to continue, but if we haven't, we'd like to jump back to our encoding scheme. So we will jump less or equal to this address. So here's our loop, which continues to run through the binary file, encoding each byte and increasing it as it goes along, checking to see whether we've reached our end address for our encoding scheme, and if not, continuing the loop. Once we've reached our last address, we need to continue and restore our previously overwritten instructions. Let's just check what these were. We overwrote these 3 instructions, so we can simply reintroduce them as part of our stub. And once these functions are introduced, we would like to allow the execution to continue as it did originally by continuing to this address. So we'll copy that address, and the last instruction in our stub will bring us back to the original point we left from. Let's save these changes once again to File, and save the new file on disk. We'll reopen this file in Ollie. And take a closer look at it.